Hello, everyone, and welcome to a joint webinar between AWS and Palo Alto Networks. Today's topic is deploying VM-Series firewalls at scale on AWS. With a combination of AWS Gateway Load Balancer and Palo Alto Networks VM-Series firewall for simple, scalable network security. I am Patrick McDowell. I'm a security architect here at AWS. I work with our security partners such as Palo Alto Networks, and I'm lucky to be joined today by Salman Syed, a senior technical marketing engineer at Palo Alto Networks. And we're here to tell you today about how the combination of the AWS Gateway Load Balancer and Palo Alto VM-Series produces game-changing network security in AWS. All right, so the most important conceptual model to think about when it comes to cloud security is what we call the shared responsibility model. You'll see a strict demarcation right in the middle between the two colors here of AWS's responsibility versus the customer's responsibility. The bottom part, which is AWS's responsibility, we refer to that as security of the cloud. We are responsible for such things as building our physical data centers, the physical security, providing raw compute, storage, databases, and networking. On the other side of the responsibility model that customers are responsible for, customers have the choice of where to store their data, how to encrypt their data, how to set up their identity and access models, how to patch their operating systems. It's the combination of AWS customers and partners like Palo Alto Networks to achieve a fully secure environment. One common misconception to call out is that, yes, if you look at the bottom right-hand corner, AWS has, as an example, PCI compliance. We help you get PCI compliance. So, for example, say if there's 30 controls needed to achieve PCI compliance, AWS might give you 20 or 66% of those controls. The 10 other controls are then the customer's responsibility. So it's everyone working in concert to achieve these joint security outcomes. So AWS is a leader in security. We have a lot of our own security services, and Palo Alto is also a leader in security and has their own security products. What Palo Alto has done is that they enhance and extend and augment our native security controls to produce a security synergy that customers can benefit. I want to give you a quick rundown of some of the native AWS controls and how we think about them. You'll see 5 pillars here of various AWS services, and this is actually something you'll find in the AWS well-architected framework as well. So the first pillar is identity and access management. Our core service that's central to all things AWS is IAM. Every single API action is authenticated and authorized, no matter what action you produce or call. There's no session, so it's authorization on demand. The next up is detective controls. You'll see things like AWS Security Hub and Amazon GuardDuty, 2 of my favorite services. You can think about GuardDuty as one-click on threat detection for the cloud, and AWS Security Hub, which has a centralization of controls as well as security events. So it's your one-stop shop for how am I doing security-wise in AWS. Maybe one of our most important services is AWS CloudTrail, which provides logs for all actions for all users in AWS. Next up, we have infrastructure protection. One of the great things about AWS is we have built-in DDoS protection with things like AWS Shield. So just by deploying your infrastructure in AWS, you are protected at some level by AWS Shield against DDoS. Now, we also have AWS Shield Advanced if you have more advanced capabilities, but you can rest easy knowing that we take DDoS very serious in AWS. Next column is data protection. We believe in encrypting everything everywhere. We want to make that easy for our customers. So we have the AWS Key Management Service, which is a FIPS 140-2 Level 2 certified HSM, and another flavor called AWS Cloud HSM, which is a FIPS 140-2 Level 3 certified HSM. And something else that's great is Amazon AWS Certificate Manager, which can provide you and auto-rotate TLS certificates for your websites. Another great service is Amazon Macie, which helps find sensitive content that you may be storing in your S3 buckets and classifies that for you. And last but not least, incident response. AWS Lambda is our serverless compute platform, which will let you take automated actions to security events. So I mentioned Amazon Guard Duty before, and that will allow you to respond to, say, hey, I noticed a malicious outbound call to a C2 server. Let me then take that alert and take a remediative action with AWS Lambda.
So VM-Series virtual next-gen firewalls provide consistent threat prevention and inline network security across cloud environments, helping network security teams regain visibility and control over traffic in their cloud networks. VM-Series offer all of the same capabilities as our industry-leading hardware firewalls in a VM form factor, making it highly automatable and scalable, a requisite for cloud environments. So the VM-Series provides customers with a broader, more complete set of security functionality that can help ensure workloads and data on AWS are protected from threats when combined with security automation. So here are what we believe to be some key VM-Series differentiators. The first one is elastic and scalable. You are provided with auto-scale templates, bootstrapping, and other automated configuration capabilities, in addition to flexible pricing to ensure that VM-Series firewalls can be easily deployed to scale with increased demand. Equally important is the fact that VM-Series firewalls can be deprecated after demand has subsided to ensure that you are not paying for unnecessary services. Second is automatic orchestration. So integration with automation and orchestration platforms such as Terraform and Ansible allow VM-Series to be deployed as part of the application development process to ensure security at DevOps speed. A tag-based policy model, tight integration across multiple cloud infrastructure providers, and a fully documented XML API allow for the creation of flexible policies that can adapt to an ever-changing environment regardless of the underlying infrastructure. The third is operationally simple or operational simplicity. Unified management from Panorama simplifies network security management even across different infrastructures and cloud. A single policy model across on-prem, private and public clouds and branches reduces gaps in the overall security posture. And the last is the best in the class security. So Palo Alto Network's comprehensive portfolio delivers best of the breed capabilities to secure the network, cloud, and ever expanding edge in a way that is integrated, automated, and simple. Our firewalls and advanced security services protect over 70,000 organizations worldwide. The VM-Series expands Layer 7 firewall capabilities by seamlessly integrating into our cloud-delivered security subscriptions, just like our other next-gen firewall like CN series container firewalls and Palo Alto series physical firewalls. We have services like threat prevention that work with the Layer 7 firewall to provide IPS capabilities by inspecting all traffic for known threats regardless of port, protocol, and encryption. Threat prevention automatically blocks vulnerabilities, buffer overflow, spyware, and malware. We have URL filtering that protects organizations against web-based threats such as phishing, malware, and C2. Inline machine learning identifies and prevents new and unknown malicious websites instantly before they can be accessed by user. We have wildfire that prevents user from multiple methods of analysis to detect and prevent unknown file-based threats. So these cloud delivered security subscriptions coordinate intelligence capabilities and provide protections across all attack vectors. This eliminates coverage gaps generated by disparate network security tools and provides a consistent platform experience to secure your organization against even the most advanced and evasive threats. So I will let Patrick talk a little bit about the Amazon Guard Duty and AWS Security Hub.
Yeah, thanks. I want to talk about real quick about Amazon Guard Duty and Security Hub. Like I said, Previously, they're two of my favorite security services and essential to AWS, and they have great integrations for our partners. So first is Amazon GuardDuty, the one-click on threat detection service that can be ingested by some Palo Alto products, as well as AWS Security Hub, which is can have two-way findings being sent to it from security products. So perhaps you want to send a security finding Security Hub, or you want a tool to ingest a finding from Security Hub. Security Hub becomes your single pane of glass view for all things security, and you can answer that question, and how secure am I in AWS? And back to Salman for the next slide.
Thank you, Patrick. Now let's take a look at the public cloud use cases. There are three main use cases for next-gen VM-Series firewall in the public cloud. First is the perimeter use case, preventing inbound threats from the internet targeted to your cloud-hosted applications. And this is where capabilities like our malware analysis solution Wildfire and our threat prevention services comes into play to be able to detect, react, and prevent both known threats with signatures and unknown threats that we might have never seen before. The other key part of perimeter protection is the ability to protect outbound traffic from the threats. The reason this is important in the public cloud is because more and more customers are developing applications in public cloud environments, and modern day applications development really hinges on the ability to connect to things like code repositories and developer resources that live outside of the environment on websites like GitHub. One of the major attack vector these days that we are seeing is attackers will actually host malicious code repositories in GitHub and other places like that in the hopes of getting unsuspecting developers to connect to those repos to pull down that malicious code and gain access to the environment. So it's just as important to protect your outbound traffic as it is to protect your inbound traffic. The second use case is segmentation. So VPCs are emerging as the new trust boundaries in public cloud environments, and next-gen firewalls are being deployed to protect all the traffic going in and out of these trust boundaries. Many organizations use VPCs to provide isolation and security boundaries for workloads. The VM-Series augments that separation through application-level segmentation policies to control traffic between VPCs and across subnets. Threat prevention policies can be used to block suspicious interactions, for example, an accounting program trying to access the source code. And third one is multi-cloud security. It's important to be able to maintain a consistent security posture across all of your different environments and all of your separate silos. And with VM-Series and our Panorama management solution, you can do exactly that, not just between your different public cloud environments, but also between your on-prem environments. Managing all of this from a single location allows you to reduce the number of tools that you have to rely on. It enables you to maintain a policy model across the entire enterprise organization environment. So one policy can be written and distributed or enforced across every component of the environment rather than having to write a single policy 3 times in different locations. And this is a massive addition to our customers. So when it comes to deploying VM-Series firewall in AWS environment, customers typically leverage on AWS Transit Gateway deployment. Like most customers, you probably connect the spoke VPCs with application workloads to the AWS Transit Gateway, and then deploy the VM-Series firewall in dedicated security VPCs and connect to the same AWS Transit Gateway. There are two trade-offs of this traditional architecture. The first one is the scale and throughput performance. Customer had two connectivity options to route outbound and east-west traffic through the VM-Series firewall in Transit Gateway environment. The first, they can deploy VM-Series with encrypted tunnels using AWS Transit Gateway VPN attachment. And then second, they can deploy VM-Series in active-passive HA mode using AWS Transit Gateway VPC attachments. So the first option provides scale using equal cost multipath routing or ECMP and multiple VPN attachment, but each VPN attachment offers a limited throughput of 1.25 gigabits. The second option uses VPC attachments that provide up to 50 gigabits of throughput, but do not scale beyond a single active VM-Series firewall. The second trade-off is the visibility and centralized firewall management. So a similar trade-off exists for inbound traffic protection. So like most customers, you likely use a sandwich architecture that forces all your inbound application traffic to flow through an inbound security VPC. This inbound security VPC hosts an auto-scaling firewall stack for threat prevention. While this architecture enables you to centrally manage firewall and security policies, it also requires the firewall to apply a source address translation or SNAT on the traffic to maintain flow symmetry, thereby obfuscating the source's identity to your applications. So the AWS Gateway Load Balancer changes the game. So with the launch of Gateway Load Balancers, customer can now simplify VM-Series firewall insertion and realize next-generation threat prevention at scale in your AWS environment. The AWS Managed Service allows you to deploy a stack of VM-Series firewall and operate in horizontally scalable and fault-tolerant manner. So the integration of VM-Series virtual firewall with Gateway Load Balancer elevate the above trade-offs. This new integration enables you to use native AWS networking constructs, such as VPC attachments, to scale your VM-Series firewalls dynamically to match your inbound, outbound, and east-west traffic. You can continue to use a centralized security VPCs as you did with Transit Gateway, but now you can leverage the Gateway Load Balancer to scale and load balance traffic across the stack of VM-Series firewall in your centralized security VPC. You can then expose the Gateway Load Balancer with the stack of firewall as a VPC endpoint services for traffic inspection and threat prevention. So this VM-Series integration and Gateway Load Balancer has three main benefits. The first is simplified connectivity. You can easily insert an auto-scaling VM-Series firewall stack in the outbound, east-west, and inbound traffic paths of your application. VM-Series and Gateway Load Balancer use the Geneva application to keep your traffic packet headers and payload intact, providing complete visibility of the source identity to your applications. In other words, no more SNAT. The performance and scale. So you can scale your traffic across multiple VM-Series firewalls at higher throughput by using native networking constructs and AWS Transit Gateway VPC attachment. You no longer need encrypted tunnels for east-west and outbound traffic inspection. So in other words, no IPsec tunnel overhead. And the last, the cost effective. Reduce the number of firewalls needed to protect your AWS environment and consolidate your overall network security posture with centralized security management.
So yeah, I wanted to continue on here and really go and reiterate the point that Gateway Load Balancer is game-changing technology. I've been at AWS for 8 years. I've been working with lots of different network appliances, whether they're firewalls, IDSs, and it was always putting a square peg into a round hole. You know, in the on-premises world, you think about virtual IPs and virtual MAC addresses to create high availability. Those things are not available in the cloud. So as Salman was saying, we are doing things like IPsec tunneling and things like this, but we want to make this as simple as possible for our customers to run their favorite tools like VM-Series in AWS. So Gateway Load Balancer removes all that heavy lifting using the Geneva protocol, as we already discussed, to automatically make seamless insertion possible. Now, this now improves your availability. A lot of customers used to think of firewalls as active passes fell over from one to the other, but now you can have a fleet of auto-scaling firewalls. You're experiencing more traffic. It's not 2 firewalls that are monitoring traffic. It's 3, it's 4, it's 5 firewalls. So they scale elastically, and this helps you reduce costs because you can scale to the amount of traffic that's incoming, and again, just overall less complex than having multiple IPsec tunnels, ELB sandwiches, things that we dealt with for years. And Gateway Load Balancer, this is its primary job. We made it just to work with our partners' security appliances like Palo Alto's VM-Series firewall.
Thanks, Patrick. So now let's talk about the overlay routing. So we have introduced the overlay routing in 10.0.5 release. So using overlay routing in your VM-Series firewall integration, the AWS Gateway Load Balancers allows you to use the two-zone policy to inspect traffic leaving your AWS environment. This allows packet to leave the VM-Series firewall through a different interface than the which they enter through. So why we need overlay routing? So for outbound traffic, customers need to add a NAT gateway between the gateway load balancer endpoint and IGW. This means the VM-Series cannot see the source IP of the workload. We only see the IP of the NAT gateway. With overlay routing, the customer doesn't need to have NAT gateway in the FVPC. And then the security policies are usually designed with two zones, private and public. So with overlay routing, customers will be able to configure two zone for outbound traffic. So when overlay routing is configured, the firewall is able to perform a layer 3 route lookup, a packet's inner header, and if the destination is the same as in the ingress interface, the packet will be directed as normal. All feature packets in the session are treated as VWAT, as if overlay routing was not enabled. And if the packet is going to the outbound destination, the firewall decapsulates the packet and forwards the packet to the IGW or NAT gateway. And then when the packet returns, the firewall reapplies the encapsulation. Now let's take a look at the traffic flows. First is the outbound traffic. So the outbound traffic is the traffic originating within the application VPCs and destined to external resources on the internet. So in the app VPC, the route table applied to the instance subnet directs traffic to the transit gateway attachment in its availability zone. On the transit gateway, the application VPC is associated with the spokes route table. The transit gateway uses the static route in that route table to forward the traffic to the security VPC. And in the security VPC, the route table applied to the subnet that contains the transit gateway attachment has a default route that forward traffic to the gateway load balancer endpoint in the attachment's availability zone. The gateway load balancer endpoint forwards the traffic to the gateway load balancers, which chooses a VM-Series firewall from its target group. The firewall receives the traffic from the gateway load balancer and associates it with the private zone, which is configured on the sub interface that is mapped to the gateway load balancer endpoints in the security VPC. The firewall applies the decryption, NAT, and security policies before forwarding it out its public data plane interface based on the default route learned from DSCP on that interface. The outbound traffic source IP address is translated to the IP address of the firewall public interface. And in the security VPC, the route table applied to the subnet that contains the firewall public interface has a default route that forward traffic to the internet gateway. Next is the east-west traffic flow. So in a transit gateway environment, east-west traffic refers to the inter-VPC traffic, such as the traffic between source and destination workloads in two different applications VPC. So in the application VPC, the route table applied to the instance subnet directs the traffic to the transit gateway attachment in its availability zone. On the transit gateway, the application VPCs are associated with the spoke route table. The transit gateway uses the static routes in the route table to forward the traffic to the security VPC. Once the packet reaches the security VPC, the route table applied to the subnet that contains the transit gateway attachment has a default route that forward traffic to the gateway load balancer endpoint in the attachment's availability zone. The gateway load balancer endpoint forwards the traffic to the gateway load balancer, which chooses a VM-Series firewall from its target group. So once the firewall receives the traffic from the gateway load balancer, it then associates it with the private zone, which is configured on the sub interface that is mapped to the gateway load balancer endpoints in the security VPC. So the firewall then applies security policies before forwarding it out its private data plane interface. So the firewall route table directs the traffic destined to the application VPC out of a private interface, because this is the same interface that received the traffic from the gateway load balancer. The firewall uses the session informations, including the TLVs associated with the Geneve encapsulation to return the traffic to the gateway load balancer. And then in the security VPC, the gateway load balancer uses the session information to forward the traffic to the gateway load balancer endpoint that received the original traffic. The route table associated with the subnet that contains the gateway load balancer endpoint has a route that forward traffic destined for the second application VPC address to the transit gateway attachment. And then on the transit gateway, the security VPC is associated with the security route table. The transit gateway uses that route table to forward traffic to the second application VPC. So now let's take a look at the inbound traffic flow. So the traffic originating outside the VPC and destined to resources within your application VPC, such as web servers. So the traffic first hit the internet gateway, and then in the application VPC, the gateway route table associated with the IGW directs the traffic to the gateway load balancer endpoint in the destination's availability zone. The gateway load balancer endpoint forwards the traffic to the gateway load balancer in the security VPC. In the security VPC, the gateway load balancer chooses a VM-Series firewall from its target group. The firewall receives the traffic from the gateway load balancer on its private data plane interface and associates it with the application zone, which is configured on the sub interface that is mapped to the gateway load balancer endpoints in the application VPC. The firewall route table directs the traffic destined to the application VPC out the private interface. The firewalls apply security policies before forwarding. The security policy is an intra-zone policy. Because this is the same interface that receives the traffic from the gateway load balancer, the firewall uses the session information, includes the TLVs associated with the Geneve encapsulation, to return the traffic to the gateway load balancer. So in the security VPC, the gateway load balancer uses the session information to forward the traffic to the gateway load balancer endpoint that received the original traffic. And then in the application VPC, the gateway load balancer endpoint forward the traffic to the internet facing load balancer. The internet facing load balancer receives the traffic and picks a target from the target group, and the targets are the application instances. Now let's talk about SSL decryption feature. So SSL decryption has always played a large role in protecting and securing your network. Without getting to see the full traffic picture, there is no way to properly protect your network, your user, or your data. So what you need is you must have a complete visibility to everything in your environment, mobile, network, cloud, in all locations. You can't stop what you can't see. You have to reduce the attack surface, right? So you have to figure out what is most important and segment your environment in a way that simplifies your ability to see and enforce. If you know it is bad, you have to stop it. You can't let a known piece of malware traverse your environment, and you have to stop new threats as quickly as possible. Take the unknown threat and reveal it, make it known, and stop it everywhere. Encrypted traffic, including malware that is encrypted, cannot be seen by the firewall. Hence, security tools cannot effectively prevent threats. So Palo Alto network firewalls can decrypt and inspect traffic to provide visibility into threats and to control protocols, certificate verification, and failure handling. Decryption can enforce policies on encrypted traffic so that firewall handles encrypted traffic according to your configured security setting. So what Palo Alto offer is we offer a rich visibility into TLS traffic, such as amount of encrypted traffic, TLS, SSL versions, cipher suites, and more, even without decryptions. We also inspect and apply policies to TLS, SSL encrypted traffic, both inbound and outbound, including for traffic that use TLS 1.3 and HTTP. We also control over use of legacy TLS protocols, insecure cipher, and incorrectly configured certs to mitigate risks. And we also help in easy deployment of decryption and built-in logs to troubleshoot issues such as application with pin certs. So now let's talk about the new feature that we have just released. So manually managing network security in the cloud can introduce significant complexity. Until today, enterprises have made operational complexity manageable by leveraging automation and infrastructure as a code templates to deploy software firewalls in AWS environments. This also can place a significant burden upon security teams responsible for managing cloud and firewall components, including deployment, routing, load balancing, high availability, and scaling. So in AWS, this translates into configuring and maintaining several resources, including EC2 instances, VPCs, Internet Gateway, Gateway Load Balancers, route tables, auto-scale groups, and more. To remove much of this complexity and potential for user error, Palo Alto Networks now deliver VM-Series next-gen firewall orchestration, so network security teams can automate the operational effort required to run virtual firewalls on AWS. So with just a few clicks and Panorama network management solution, VM-Series customers can rapidly deploy, manage, scale, and monitor their virtual next-gen firewalls. In addition to VM-Series firewall configuration and licensing, Panorama also configures all the AWS resources the VM-Series firewall requires. So VM-Series next-gen firewall orchestration for AWS consolidates all configuration tasks into a single workflow and removes the complex aspects of deploying, scaling, and provisioning VM-Series in your AWS environment. So VM-Series Firewall seamless integration with AWS Gateway Load Balancer provides a better business outcome to the organizations, such as speed and agility. It also automates your security protection and scales with your AWS environment. It also provides consistent security across your global environment, as well as continuous governance and compliance to make sure that there are no data breaches. And most importantly, it reduces operational cost and complexity to secure your cloud environment and application. So simple, fast, and secure are the primary considerations that you should have in your journey to the cloud.
And that brings us to the end. Thanks for joining, everyone. You can reach out to this email address right here, schedule a meeting, and get a $250 AWS cloud credit for your own account to use. Once again, thank you so much for joining. It was a pleasure to co-present this to you, and I hope you learned a lot about what we offer in terms of network security with Gateway Load Balancer and Palo Alto Networks VM-Series in AWS. Thanks.